Hello and welcome to Lesson 4. In this topic, we are going to discuss problem solving and reasoning. In this lesson, we will define problem solving and reasoning. We shall also discuss the method of Polya in solving problems and differentiate inductive and deductive reasoning. Regardless of the area of specialization you chose in college or your role in society, it is usual for us to encounter problems and necessarily solve these problems. For example, if you choose to enroll in accountancy, you will encounter problems in balancing financial statements. If you chose to enroll in physical therapy, then you will normally encounter problems on physiological interventions. In our area of specialization, the computer technology, it is usual for us to encounter problems related to network connectivity, system failure, and programming logic. As a computer technology student, you shall have subjects in computer programming wherein problem solving is a common task. In fact, writing codes or programs that correctly solve a computing problem will be an integral part of your course studies in programming. In general, as a BS Industrial Technology student, you should be able to apply your mathematical abilities to give practical solutions to industrial problems. So I suggest that you focus on this part of our lesson because this would help you in your programming subject come second semester. So what is problem solving? There is a Hungarian mathematician in the name of George Polya who said that problem solving is finding a way around a difficulty, around an obstacle, and finding a solution to a problem that is unknown. Polya introduced a four-step process for solving a problem. These four-step processes are understanding the problem, devising a plan, carrying out the plan, and looking back. To understand the problem, you have to define the problem in terms of its parameters and requirements. You have to look for the given information, determine what is the unknown, what are the given data or parameters, what are the conditions, and check if the conditions are enough to determine the unknown. You also have to think in terms of a picture or diagram to visualize the information. It could also help to restate the problem in your own words and see whether you understand all the words used in the problem and know what is being asked. Once you have understood the problem, a systematic plan should be made. There are many reasonable ways to solve a problem. Some strategies are making use of symbols to represent the problem in an equation, making a calculated guess, going through the process, or revising the problem to a simpler form. In computer programming, this is devising the algorithm. An algorithm is the step-by-step process to solve a computing problem. You will learn more about algorithms in Programming 1. Once a plan was laid out, you can carry out the plan using your mathematical knowledge and skills and logical thinking or reasoning. After solving or coming up with a solution, you need to look back and verify if your solution is valid. If necessary, improve on your solution by looking for alternative plans. Integral to Polya's method is logical reasoning or simply reasoning. Logical reasoning is a form of thinking in which premises and relations between premises are used in a rigorous manner to infer conclusions that are entailed or implied by the premises and the relations. A premise is a statement that is assumed to be true, which is the basis of a logical argument. There are two forms of logical reasoning. One is inductive, which is the process of reaching a general conclusion by examining specific examples. The second one is deductive, which is the process of reaching a specific conclusion by applying general assumptions, procedures, or principles. Inductive is from a specific given to a general conclusion, while deductive starts from a given general statement to a specific conclusion. In this section, let's consider some problems that involve inductive and deductive reasoning, and let's see how we can use Polya's method to aid us in solving problems. In this set of problems, which involve number patterns, we'll employ inductive reasoning to find the next term in the sequence. Let's start with the sequence 3, 6, 9, 12, 15. Employing Polya's method, we first try to understand the problem. First, we have to understand that the problem involves a number sequence. Since it is a sequence, there must be a pattern. So we have to find out the pattern to be able to find the term after 15. Next, we devise a plan. There are various strategies that can be applied depending on the type of problem. In this case, we need to find out how the numbers progress or change. Simple analysis would tell us that the next number is 3 more than the previous number. Hence, to get the second term, we add 3 to the first term. That is, 3 plus 3 equals 6. To get the third term, we add 3 to the second term, and so on. With the strategy we made, we can now carry out the plan and determine the term after 15, that is, the sixth term. So we add 3 to 15 to get 18, hence the sixth term is 18. Looking back, we have to determine whether the sixth term followed that pattern derived in step 2. We notice that every term is 3 more than the previous term, hence our solution is correct. Let us consider the second pattern, which includes 1, 3, 6, 10, and 15. In this section, I will no longer show you the complete steps in Polya's method to shorten the video. However, in your tasks or activities, you should show all 4 steps. Looking at how the numbers progress, each term is derived by adding a number from another set of sequence starting with 2. The second term is derived by adding 2 to the first term. The third term is derived by adding 3 to the second term, and so on. Hence, to get the sixth term, we add 6 to 15, which yields 21. How about the third number sequence? Can you find the missing term? You may pause this video now and try to solve it on your own. Okay, so the missing term is 65. Let us consider another interesting problem involving patterns. We have here some figures involving operations. Applying Polya's method, first we have to understand the problem. In this case, the shapes represent values. The first 3 patterns are the clues, and we ought to find the result of the last pattern. In step 2, we employ substitution to represent the figures with variables, A for arrow, B for heart, and C for diamond. Next, we translate the figures into mathematical statements. Arrow plus arrow equals 16 will be A plus A equals 16. Heart times arrow equals 16 will now become B times A equals 16. Diamond minus heart equals 16 will be represented by C minus B equals 16. Diamond plus heart plus arrow equals blank will now be C plus B plus A equals blank. We now follow through the process by applying our mathematical knowledge and skills to solve the equations. This is carrying out the plan. Considering the first mathematical statement, A plus A equals 16, this can be simplified to 2A equals 16. Dividing both sides of the equation by 2 will give us 16 over 2 equals 8 on the right side. On the left side, 2 over 2 equals 1. Hence, 1 times A equals 8, or A equals 8. For the second mathematical statement, B times A equals 16, we substitute the value of A, which is 8. So we have the equation 8B equals 16. Dividing both sides of the equation by 8 will give us b equals 2. For the third equation, c minus b equals 16, we substitute the value of b, which is 2, and will give us a value for c equals 18. Finally, for the last pattern represented by the equation c plus b plus a, substituting values of c, b, and a will yield 28. Hence, the pattern diamond plus heart plus arrow equals 28. Now, this time, we'll solve a puzzle with deductive reasoning. Note that in deductive reasoning, we have a general premise that would lead us to a specific conclusion. You may pause this video and read carefully the problem. The general premise here is that Jim, Joy, John, and Jane were elected officers of the organization, while the specific conclusion will be the position of each elected officer. Applying Polio's method, it should be clear that our goal here is to pair the names with the position, and the three statements are our clues. Our strategy to solve this problem is to use the process of elimination. To figure out the pairing of names with the position, we have to create a chart to represent the names and position. To carry out our plan, we now create a table that contains the name against the positions. What we shall do here is to cross out the cell or the box wherein the name cannot be paired with the position. So starting with the first clue, Jane is younger than the president but older than the treasurer. This implies that Jane is neither the president nor the treasurer. The second clue states that Jim and the secretary are both the same age and they are the younger members of the group. This implies then that Jim is not the secretary also. For the third clue, John and the secretary are next door neighbors. This statement also tells us that John is not the secretary. At this point, we already have used the three clues. Our strategy now is to find relationships between statements. Analyzing further statement number 2 in relation to number 1, we can conclude that Jane is not the secretary because the secretary must be the youngest member of the group. However, Jane is younger than the president but older than the treasurer. In other words, there is someone younger than Jane. Hence, the secretary is Joy. If Joy is the secretary, she cannot be the president, the vice president, and the treasurer. Looking at Jane's row, all other positions are crossed out except vice president. Hence, Jane must be the vice president. Since we have concluded that Jane is the vice president, it follows that Jim and John are not the vice president. In statement 2, Jim and the secretary are both the youngest members of the group. Hence, Jim cannot be the president, because from statement 1, the president is older than Jim. And so, Jim must be the treasurer. Lastly, we can now conclude that John must be the president. In step 4, we verify our conclusions based on the premises.